Statistics show up everywhere. They're in the news constantly, bombarding us. And sometimes they're used well, sometimes they're not. So in this course, we're going to learn to kind of read the statistics that are given to us and to be more informed consumers of them, as well as to actually generate some statistics ourselves. And a topic that goes hand in hand with statistics and is really necessary to do a lot of the statistical inference that we want to do is probability. So we're actually going to spend probably half of this class talking about probability and some ideas that arise in probability. So if you read through sections 1.1 and 1.2 of your textbook, it brings up some basic ideas and basic terminology that shows up in statistics. And I just wanted to talk really briefly about some of that. So there's this idea of populations versus samples. So a sample is a collection of observations that you make from a population. So you have the whole group of people and you're going to choose a select few of them that are then you're going to take observations from to represent the entire population. So whenever you do this, you have to be careful about how you pick your sample. So there's different ways to choose a sample. The most preferred method is generally simple random sampling. And what that means is what we're going to do is when you choose people, every person has the exact same chance of being chosen as the next person. And what that ends up doing is every sample that, say, has 10 people in it has the same chance of being chosen. So that's simple random sampling. All right. You can do some other types of sampling, but those other types of sampling always have some kind of bias involved. But there are times that it's very desirable to do other types of sampling, and that'll come up throughout this class. We'll talk about that at different points. Simple random sampling is actually very hard to achieve sometimes in reality. All right, so the other thing that comes up a lot in this is this idea of inferential statistics versus descriptive statistics. So descriptive statistics is probably what you've seen the most in your math career. Hopefully what we'll talk about today will be review of probably about 6th grade when you learned to take the mean, median, and mode, those 3 M's of a set of data. So that's descriptive statistics. And we'll talk about descriptive statistics this week, and then we'll be headed into inferential statistics. But to get to inferential statistics, we need probability, so we'll be doing a lot of probability before we really truly get there. Inferential statistics are the statistics that are that are designed to contribute to some kind of process that lets us make scientific judgments, right? So, think about experiments, right? So, we've got a lot of uncertainty, a lot of variation, and we want to be able to make some kind of scientific judgment. In a scientific experiment setup, we would be able to take out the uncertainty and variation. And unfortunately, in real life, we can't always do that, and so that's where statistics jumps in and helps the scientific process. It allows us to do this inferential statistics thing, all right? Descriptive statistics, what they do is they provide us kind of a picture, a snapshot of what we're looking at. So we can think about knowing about where the data lies on a number line maybe, or knowing about how broad the data is. So that's what descriptive statistics are doing. Probability comes in when we want to do the inferential statistics. Like I said, what probability does is it allows us to quantify how confident we can be in the outcomes, the conclusions that we reach using the statistical inference, using those inferential statistics. So we want to have some kind of confidence, and in order to do that, we need to have some rules of probability and some probability background to allow us to have some confidence there. All right, so we want to talk about some measures of central tendency. So that's a lot of big words, but what we're talking about when we talk about the measures of central tendency is the three M's. So we're talking about the mean, the median, and the mode. So we're going to start off. Here's my data set. I have a sample here of values, and I'm going to use them to find a sample mean, a sample median, and a sample mode. So sample mean is written as x with a bar over it. We call it x bar actually. And it's equal to the sum from I equals 1 to n of our our data values in our sample. So x sub I divided by n. All right, so what this looks like is our first data value plus our second data value plus all the way up to adding in our nth data value. And then we end up dividing all of that by n. So if I were to do that with this sample, I would get this example that I have. I'd be looking for my sample mean, x bar, and then I would be adding up all of my data values and dividing by how many there are. So I'll be doing 1.7 plus 2.2 plus 3.9 plus 3.11 plus 14.7 all divided by the number of values. So I count up how many values I have. I have 1, 2, 3, 4, 5 values. So I'll divide by 5. And when I do that, I end up with hopefully you're adding this up along with me, checking to make sure I don't make mistakes. 1.7 plus 2.2 plus 3.9 plus 3.11 plus 14.7 gives us 25.61 all divided by 5, which gives us 5.122. All right. So we have a sample mean. So this is our sample mean. All right. And it's really important that it's a lowercase x here. We use lowercase letters when we're talking about samples. All right. And that'll become more important as we move on. So the next thing that we want to talk about with measures of central tendency is we want to talk about a sample median. So to do this, we're going to have our data x1, x2, all the way up to xn. Is the sample arranged in increasing order. And when we have that, then we have x with a tilde over the top of it, right, is equal to, and now the median depends on whether we have an even or an odd number of data points. So we have x sub n plus 1, n plus 1 divided by 2, all right? If n is odd, sorry about the terrible handwriting here, if, all right? And we have x sub we have 1/2, sorry. 1/2 times x sub n divided by 2 plus x sub n plus 1 divided by 2 if n is even. So we have two different ways that we can go. So taking a look at this, we look at what we have in our sample. Remember, we had 5 elements, so we're in the n is odd case. So we have x1, x2, x5 as our data. So we have x1, and we want increasing order, so we're going to take the minimum one. So we have 1.7. x2 for us is going to be 2.2. We were lucky they were already arranged for us. So x3 is going to be 3.9. x4 is 3.11. And x5 is going to be 14.7. So since n equals 5, which is odd, I have x tilde is going to be equal to x sub 5 plus 1 divided by 2. So I'm going to do that. I have x sub 6 divided by 2. So I'm looking for x sub 3. So x sub 3 was 3.9. So that's going to be my median. So this is our sample median. All right, so the other option here is to have a mode. That's the final thing. All right, so the mode is the value that shows up most often. In the sample. So for our sample, we have no number showing up more than once, and so we actually have no mode. All right. If a number showed up twice, then that number would be the mode. If 2 numbers showed up twice, both of them would be the mode. The only time that you don't have a mode is when no number shows up more than one time in your sample. So that's the three main measures of central tendency for a sample. Again, make sure you're using lowercase